We have here 2 all over x squared times x plus 3. Okay, so this example is a little bit different because um, we have an exponent. We have factors that's being repeated. We have an exponent of 2 here. Okay, so we're going to set up our um, partial fraction component differently. So what we will have to do, I'm going to write this down. This is going to be key. You will need a partial fraction for each exponent from 1 up. Meaning, here's our question. 2 all over x squared times x plus 3 equals to, we have x squared. So we're going to create a partial fraction for this x squared for each. So starting with x, then x squared, and then we have our x plus 3. So our unknowns a, b, and c. Okay, so now at this moment here, we want to get rid of the denominator, and we're going to do that by multiplying all terms on both sides by the LCD. And our LCD is x squared times x plus 3. That is our LCD. So because of room's sake, let's do it this way, noting that we can distribute this x squared to each term. So on the right hand side, the left hand side, the x squared, x plus 3's cancel. We have 2 is equal to. Now on the right hand side, let's look at the first term in our LCD. X goes into x squared, x times. So then we're left with a times x plus 3. The second term, the x squareds cancel out. I'll take out everything here. The x squared cancels out. Then you're left with b times x plus 3. And then for c, our x plus 3's cancel out. And then we're left with c times x squared. Okay, now for this example, this is one of those examples where I said, okay, from the previous videos of this, I said that finding the roots or zeros may work, it may not work, because for this example, we have a root of -3. It's going to cancel out a and b, and we will find c. Okay, that's okay. And then we have when x is 0, okay, it'll cancel out a and b, a and c leaves us with b, finding b, but we don't have anything that would cancel out the a. So this is where I would not find the roots for this example. I would go ahead and set up this question as a system of linear equations, and we find a, b, and c that way. So that's how we're going to solve this particular example. So let's go ahead and distribute your ax and the b. We have 2 is equal to ax squared plus 3ax when we distribute both of those. Then we're going to distribute the b. We have bx plus 3b plus cx squared. Let's combine our terms, our like terms, our x squareds, our x's, and our constant. And as we gather, these are our x squares, this is our x term, we have our constant. Let's factor out the x squared. So we have 2 is equal to a plus c times x squared, plus factor out the x for our x term. We have 3a plus b times x, and then we have our constant term 3b. So let's set up our system. Okay, so we want our first equation, our first line is going to represent the x squared. So on the left hand side, do you have an x squared on the left hand side? Well, we say no. So therefore, we're going to say 0 is equal to, look at the coefficients of x squared. We have a plus c. Our second line, our second equation will represent the x term. Well, do we have an x term on the left hand side? No. So we're going to say 0 is equal to, and look at your coefficients for your x term. We have 3a plus b. And then lastly, our last line will represent our constant terms. So we do have a constant term of 2 on the left-hand side. So 2 is equal to 3b. Here's our system. Now, how you choose it, we can do back substitution. You can use the elimination method. It doesn't matter. But since the last equation, 2 is equal to 3b, find b. B is equal to 2/3. So we have B. Let's find A and C next. Okay, so let's find A. We're going to use the second equation. Zero is equal to 3a plus b. 0 is equal to 3a plus 2/3. Multiply every term by 3. We have 3 is equal to 9a plus 2. That's not, if you saw that mistake, put 0 there because we multiply by both sides by 3. That's going to give us 0. Subtract 2 to both sides. We have negative 2 is equal to 9a. And then divide by 9. We have this as a solution. Negative 2 over 9. Now let's find C. 0 is equal to a plus c. 0 is equal to negative 2 over 9 plus c. Multiply every term by 9. We have 0 is equal to negative 2 plus 9c. Add 2 to each side and then divide by 9. We have 2/9, which is equal to c. So now we have our A, B, and C, and we're going to plug it back into our partial fractions. And let's go ahead and do that. Okay, so we have here A, we said negative 2/9 over x. B, we said 2/3 over x squared. And then C, we have 2/9 over x plus 3. Or we can write it as negative 2 over 9x plus 2 over 3x squared plus 2 over 9 times x plus 3. There we go. We have our solutions.